You are in a terminal at the end of a long debugging session. The agent has found the bug. It now asks to run one more command. The command looks harmless, but it has write access to the repository, the network, and a deployment script. Your cursor hovers over approve. That is the moment when tools stop being convenience and become production risk. This is lesson 6 in the Claude Code Production Agent course. Tools, the hands of the agent. Subscribe for the full Claude Code Production Agent course. This lesson starts the primitive stack we introduced last time. In lesson 5, we defined production with 5 properties: observable, reversible, evaluable, governable, and change controlled. That matters today because tools are where those properties become real. A model can propose, a tool can act. The pain point is simple. Teams treat tools like buttons: a search tool, a file edit tool, a shell tool, an API tool. But in a production agent, a tool is not a button. A tool is a contract. It defines what the agent may ask for, what the system will do, what evidence comes back, and what failure looks like. There is a map for tool risk. Read-only tools usually have lower blast radius. Write tools change state. External API tools cross a system boundary. Money, deployment, customer data, secrets, and identity tools need the strongest controls. The same agent can be safe with one tool and dangerous with another. The visible artifact for this lesson is the tool risk map. Put every tool into a category: read-only, write, external API, production action, or sensitive identity action. Then ask 4 questions. What can this tool touch? What can it change? What evidence does it return? What happens when it fails? A useful mental model is a workshop. A model is the person making a suggestion. The tool is the saw, the drill, or the machine press. You do not make a workshop safe by hiring a cleverer person alone. You also design handles, guards, stop buttons, labels, maintenance routines, and training. The same is true for agent tools. The interface around the action is part of the safety system. Consider a release note agent. It reads merge pull requests, groups them by feature area, drafts release notes, and returns links to the source changes. That can be valuable with relatively low risk if the tool is read-only and the final text is reviewed by a human. The evidence output should include the pull requests, commit links, and any assumptions used in the summary. Now compare that with an agent that edits production configuration. The model may be the same, the workflow may look similar, but the risk category is completely different. That tool needs explicit approval, a scoped path, a rollback plan, a dry run option, and an audit trail. The production question is not whether the model is smart, it is whether the action boundary is safe. Here is a checklist I would use before adding a tool. Is the schema narrow enough that the model cannot smuggle a broad instruction into a free text field? Is the permission boundary explicit? Does the tool return evidence the next model turn can reason from? Is there an owner and a version? If those answers are weak, the tool is not ready for a production loop. Failure handling is also design. A timeout should be visible. A partial write should be reported as partial, not success. Retries should be bounded. External AP should expose rate limit responses clearly. The worst tool result is a vague success message that hides uncertainty because the agent will build the next decision on a false foundation. Finally, cost is a production signal. Tool calls can consume tokens, API quota, money, and human attention. A mature tool layer makes cost visible enough to reason about. If you cannot tell how often a tool is called, how often it fails, and what it costs, you do not yet have an operating model. Schemas are part of governance. A good tool schema narrows the action. It uses typed fields instead of vague text. It validates paths, IDs, and ranges. It avoids hidden defaults. It returns evidence, not just success. The schema is not boring plumbing. It is how you prevent the agent from turning a broad intention into an unsafe action. A safe tool workflow has 5 steps: request, validate, execute, record, return evidence, the agent asks. The runtime checks, the tool acts, the system records what happened. The result goes back into the transcript so the next model turn can reason from facts, not vibes. The common mistake is tool sprawl. Teams add a dozen tools because it feels powerful. Then nobody knows which tool owns which action, which version is live, which permissions are required, or how much each call costs. The agent looks smarter, but the operating model becomes weaker. Let us recap lesson 6. Tools are the hands of the agent. Tool categories define risk. Schemas are governance. Evidence is part of the output. Versioning, rate limiting, error handling, and cost attribution are production concerns, not afterthoughts. The lesson learned is this: do not trust the brain until you have designed the hand. The model may suggest the right action, but the tool layer decides whether that action is safe, observable, reversible, and governable. Subscribe for the full Claude Code Production Agent course. The Claude Code book is available as a companion resource in the description if you want the deeper written version. In Lesson 7, we look at subagents and delegation, when to spawn another worker, and when that creates chaos.